All right, so in this video, they tell us that two distinct triangles can be created with these following values. They want the measure of side AC for each triangle. So here, I'm looking for this bottom leg. So they tell us that AB is 16. They tell us that BC is 14. And they tell us that the measure of angle A is 23 degrees. All right, so here they want the measure of leg AC. Well, leg AC is directly across from angle B. So if I want the measure of AC, I need to know what angle B is. Since I don't have an angle for B, I'm going to have to find C first. So we're going to have to solve for this angle here. So I'll set that up by saying sine of x divided by 16 is equal to sine of 23 over 14. Since we want sine of x by itself, we're going to multiply each side by 16. So now I have sine of x equals 16 times sine of 23, and this will all be over 14. Now, to get x by itself, we're going to have to take the inverse here. So x will be equal to sine inverse of 16 times sine 23, and this is all over 14. All right, so this is going to give us 26.5. So that's going to be the value of angle C here. Now that I have these two angles, I can easily find the value of angle B, because I know that all three angles in a triangle have to add up to 180. So B here is going to be 130.5. Now that I know the measure of angle B, I can find the leg length for side AC here. So let me just do a little divider here, and we'll go ahead and set our work up to find AC1. So we know we're going to have to use the 130.5 over this unknown value. So I'll say sine of 130.5, and I will put this over, we'll call it y. And for the ratio, I'm going to use the angle and this leg given to me from this information. So this will be sine of 23, and this will all be over 14. So here, we're going to cross multiply. So I have y times sine 23 equals 14 times sine of 130.5. And to get y by itself, I will need to divide here. So now we know that y is equal to this fraction here. So I have 14 times sine of 130.5, and I'm going to divide that by sine of 23. So AC1 is going to be 27.2. Now I need to find AC2. Well, remember in the prior video, we know that this is the pivoting leg. So this leg is going to move inward here. Okay, so what I'm going to do is I'm going to take this leg BC and I'm going to allow it to pivot over here. So if I trace this out here, like so, and then it pivots this way, I can see where, because this is 26.5, that this leg also has to be 26.5. And now I can find this obtuse angle and the measure of B2. Finding the measure of B2 will help me find this AC2. So we'll put right here that this is actually C2. All right, and we're going to zoom in so that we can see this just a little bit better. So I'll say 180 minus 26.5, and that gives me 153.5. Now, these two angles added together and subtracted from 180 will give me this angle B2. Which is 3.5. So here, this angle is 3.5 degrees. Now that I know that this is 3.5 degrees, it's going to be pretty easy to find this length here from A to C2. So I'll go ahead and do another divider here. And since this is 14, I also know that this white segment here is 14. So that can be my first ratio. I can say sine of 23 over 14 equals sine of 3.5 over AC2. We'll call that Z. So again, I'll have to solve this by cross multiplying. So I have Z times sine 23 equals 14 times sine of 3.5. And then I will divide each side by sine 23. So Z here will equal 14 times sine of 3.5 divided by sine of 23, and that gives me 2.2. So that would be the value of AC2. All right, that's going to be all for this video. If you have any questions, please leave them in the comments, and we'll see you all in the next video.